Today we're going to learn how to classify shapes in the coordinate plane. So in this lesson, we're going to learn how to classify shapes in the coordinate plane, which I literally just said. So you can follow along using the capture sheet that was shared by your teacher, and you can also access it in the description box below. It's a Google Doc, so you can fill it in, or you can print it and write on it with pencil and paper if you prefer. So before we begin, let's review several concepts that we have already learned this year that we're going to use to perform these classifications. Teaching is hard. Okay, so the first thing that you need to know is parallel slopes. So parallel slopes are slopes that are the same. Parallel lines have the same slope. Perpendicular slopes are lines that have slopes that are negative reciprocals. I just said perpendicular slopes are lines. I think you guys know what I mean. I don't know why I'm struggling so much at the beginning here, but fun, really fun. You also need to know about the types and properties of triangles, and we're going to give you a resource to help you with that, as well as the types and properties of quadrilaterals. So here's our first example, and again, you want to be following along on your capture sheet. The first example is about a triangle. It asks, what type of triangle is ABC if the vertices are located at 15.2, 5.8, and 11.9? So you're going to want to click on the link in your capture sheet that takes you to this sheet on properties of triangles. You are going to be prompted to make a copy. You can keep it, you can print it out, but you definitely will want this resource sheet when you are taking your quiz this week. As you're working through the practice, this is important and you will need it. So pause the video and read this over to refresh your memory about the types of triangles and what properties they have. Now that you've reviewed the list of triangles, we want you to think of a strategy that you could use to classify it. So what could you calculate from these coordinates? You're going to list what you need to know to classify this triangle in this box. Well, not this box, the box on your capture sheet. Pause the video while you make that list. So you might need to know what this triangle looks like, what the slopes of its sides are, and what the lengths of its sides are. So we're going to calculate that together using our capture sheet. The first question, what does the triangle look like? So if you have graph paper, you could use that. I went online and used Desmos. It can be a little tricky to get this to work, but you have to put the line segments in. The triangle looks like this. So just based on the looks of this triangle, I think it could be a right triangle. This angle right here looks like it might be a right angle. I'm not sure though. It also looks like it could be isosceles. This length here for BC and this length here for BA look like they might be the same length. It's really important though that we don't assume that this is a right isosceles triangle because looks can be deceiving. So we don't want you to make any guesses or assumptions based on how your shape looks. That will mainly help you make a theory or a hypothesis about what type this is. Once you have this idea, then we are actually going to do the math to make sure that our thought is correct. So moving down on your capture sheet to the table, we're going to find the length and the slope of each side. So to find the slope, that's the change in y over the change in x, or y2 minus y1 over x2 minus x1. And to find the lengths, we are going to use the distance formula. In our last video, we worked on the distance formula, which is basically just the Pythagorean theorem, so you'll be doing that again. So finding the slopes for AB, BC, and AC, I recommend you pause your video and do this work. Then you can come back here and check to make sure you did it right. Here's AB, BC, and AC. When you find your slopes, the change in y on the top is really the same thing as what's going into your y2 minus y1, and your change in x is the same thing as what's going into x2 minus x1 in the distance formula. So for example, when I'm finding the length of side AB, notice that I had 6 over 10 here, and I also have 6 squared plus 10 squared here. So once you find that change in y and that change in x, you can plug them straight into your distance formula. Same thing for BC. Notice I had 11 over 6 as my slope, and it's 11 squared plus 6 squared. Finally, for AC, I have -17/4 as my slope, and that shows up again as 17 squared and 4 squared in the distance formula. All right, so now we have found the slope and the length of each side, and we're going to begin classifying this triangle now that we have this information. So there's one way to classify triangles, which is by looking at the side lengths that we found. So the side lengths were the square root of 136, the square root of 157, and the square root of 305. You could approximate these and round them, but honestly, you can just leave them like this and it's still going to serve the purposes that we need it to. So looking at our notes document, properties of triangles, we have 3 different ways that we can categorize triangles based on the lengths of their sides. Triangles can be scalene, isosceles, or equilateral. And scalene triangles have 3 different side lengths, isosceles have 2 side lengths that are the same, and equilateral has 3 equal sides. Just looking at our side lengths, we can see that this is scalene. Remember, we thought it might be isosceles because the square root of 136 and 157 are probably close enough together that they looked like they were the same, but good thing we did the math because it's not isosceles, it's scalene. Moving on, we can also classify triangles based on the angles that they have. We actually need side lengths and slopes for this, not just the slopes. So bringing our side lengths back in and bringing our slopes in that we already calculated, now we can categorize it based on these 3 types. So the 3 types of triangles based on angle are right triangles, acute triangles, and obtuse triangles. So, taking a look at right triangles first, we would need one angle to be 90 degrees. This would mean that our slopes would have to include a pair of negative reciprocals. Taking a look at our slopes that we calculated, we do not have a pair of negative reciprocals, so this is not a right triangle. Remember, when we were looking at the original triangle, we thought that maybe it was a right triangle, but it turns out it's not. Now we have to decide whether it's acute or obtuse. And this depends on whether the angle is greater or less than 90 degrees. You can't actually use the slopes for that, which is why we brought the side lengths back. They're over here. So if you take a look at number 2 in both of those, we have either the length of the longest side squared is less than the sum of the squares of the remaining 2 sides. We'll talk about what that means. Or the length of the longest side squared is greater than the sum of the squares of the other 2 sides. So basically, we need to think about our side lengths in terms of small, medium, and large. And when you add up the small and medium, either they're bigger than the large side or they're smaller. So taking our side lengths, if you add up 157 and 136, which is the square of the small and medium sides, it adds up to 293. And 293 is less than 305, which is our largest side squared. So this fits the property of an obtuse triangle, because in an obtuse triangle, the length of the longest side squared is greater than the sum of the squares of the remaining 2 sides. So basically, you're just checking to see that the small and the medium add up to less than the large, and then your triangle is obtuse. So now that we have gone through all of that, we can make a final statement about what type of triangle ABC is. For every triangle that you categorize, it needs to be categorized based on its sides and based on its angles. So it needs to be categorized as either scalene, isosceles, or equilateral, and right, obtuse, or acute. So based on everything we know, we can say that this triangle ABC is a scalene, obtuse triangle. In the box, we're going to also write why. So a big part of this is justifying it correctly. So the justification is just as important as the identification. So here is an example of what your justification could look like. It is scalene because none of the side lengths are the same. That's your justification for the first part. It's obtuse because none of the slopes are negative reciprocals. That rules out the right angle part. And the longest side squared is greater than the sum of the other 2 sides squared. So this is how you categorize triangles in the coordinate plane. And now we're going to move on to a quadrilateral. The question asks us what type of quadrilateral ABCD is, and it's given our 4 vertices here. So you're going to click on the notes in your capture sheet, and you will also have a list of the types of quadrilaterals and the properties that each one has. Please review that for a few moments, pause the video while you do that, and then come back so we can classify a quadrilateral. So just like before, on your capture sheet, you're going to begin by listing what you need to know to classify this shape. Take a moment and make a list of everything you'd like to know. Just like the triangle, you'd probably like to know what this quadrilateral looks like. Just picturing it on the grid is helpful in terms of ruling things out or making a guess about what type it is. Just like the triangle, we also want to know what the slopes of its sides are and what the lengths of its sides are. So going to that first question, what does the quadrilateral look like? You can use a piece of graph paper or you can use an online graphing tool to take these points and plot them. ABCD looks like this. Start to think to yourself, what shape could this be? As I'm looking at this, I think it could maybe be a parallelogram, or it could possibly be a rhombus. It does not look like a square or a rectangle or a kite. I guess it's possible that it's a kite, but to me it looks like a parallelogram or a rhombus. But just like last time, we have to do the math. We can't just guess based on assumptions of what we see. So you're going to move down to the table on your capture sheet. And now we're going to find the slopes and the lengths of each side. Just as before, slope is found using change in y over change in x, and that gives you useful information to find the side lengths. Now would be a great time to pause the video, do all of those calculations, and then return to the video when you are ready. So I'm going to fill in all our slopes here. (13, 7/11, 13, and 7/11, an interesting pattern. I'm also going to fill in all of our lengths. So all sides have a length of the square root of 4,250. Interesting. So taking our slopes and our lengths and the visualization that we have, so we have the visual and then all of the slopes and the lengths as well. Now we can start trying to decide what type of quadrilateral this is. So you're going to want to open a new tab or take your printed copy and look at the properties of quadrilaterals sheet. So the first option we have here is parallelogram, and we thought that maybe this was a parallelogram. So here are the requirements that it would need to have. The parallel sides are parallel. Basically, I was trying to say that the opposite sides are parallel. I mean, that's what the document said, but yes, the opposite sides are parallel. So our opposite sides are BC and AD. They have a slope of 7/11, and the opposite sides AB and CD have a slope of 13. So it is true that we have parallel sides in our parallelogram. Also, the opposite sides are supposed to be congruent. Well, all of our sides are congruent, so yes, I can safely say that this is a parallelogram based on the fact that all of the sides are congruent, the opposite sides are congruent, the opposite sides are parallel. Moving down to a rectangle, it does say that all angles would have to be right angles. And in kites, it says the disjoint pair of consecutive sides are congruent. Just looking at this, it's not a rectangle, and it's probably not a kite either. We can look at that when it comes to the diagonals, but I'm telling you, it's not right. Okay, so we have 3 more options from our I just kicked something. We have 3 more options from our sheet that we can look over. Rhombuses, squares, and trapezoids. So we thought that this might be a rhombus. Let's take a look at our requirements. So all properties of a parallelogram apply. Well, we did already establish that this is a parallelogram, so we're good. Then it says in number 3, all sides are congruent. Yes, all sides are congruent. So we have a parallelogram with congruent sides. This is a rhombus. For a square, it would have to be a rectangle. We already established that it is not a rectangle. And also, look at it, it's not a rectangle. So it's not a square, and again, look at it, it's not a trapezoid. So ABCD officially is a rhombus. We need to fill in why, because it's important that we can justify our work here. So take a moment and fill in on your capture sheet why this is a rhombus, and then you can take a look at my response. So I'm going to begin by justifying that it's a parallelogram because a rhombus is a parallelogram. So it's a parallelogram because opposite sides have the same length and slope, and then it's specifically a rhombus because all sides are congruent. I also am sharing that no slopes are negative reciprocals, so it rules out the idea that it could be a square or a rectangle. This is a level of detail we'll expect when you're justifying your work this week. We could have also taken a different approach. We could have been using the diagonals of the shape to help us. So if you wanted to take this approach, this is an option. So AC and BD are the diagonals of our shape, and we can find the slopes, the lengths, and the midpoints of these diagonals to help us determine some things about the properties of this shape. So I'm going to pull up the slopes, lengths, and midpoints. And here are some things that we notice once we've done these calculations. The slopes, -3/5 and 5/3, are negative reciprocals. So that means that this angle that connects AC and DB is a right angle. So our diagonals are perpendicular. That's one thing that we just learned from our calculations. Let's take a look at the midpoints. -10, and -10. So this tells us that our diagonals are bisecting each other. So we have diagonals that are perpendicular bisectors. Well, taking a look at our sheet, one property of rhombuses is that the diagonals are perpendicular bisectors of each other. So if you prefer, you can just take this approach instead of doing all of the sides, the lengths and slopes of all the sides. You can just do the slopes, lengths, and midpoints of the diagonals instead, and that would have also given you conclusive information that this is a rhombus. If you wanted to do a justification for why this is a rhombus based on the diagonals, it would look something like this. The diagonals share a midpoint at -10, so they bisect each other. This makes ABCD a parallelogram. They are not the same length, so it's not a rectangle or a square. They are perpendicular, so it is a rhombus. So the rhombus is the only shape that has perpendicular bisectors. A square does too, but in a square, they also have to be the same length, and we checked the length, and these are not the same, so it's not a square. So that's all we have for you today for classifying shapes in the coordinate plane. All right, I know this was a lot. Hopefully you were able to pause the video and use your capture sheet to help you, because I think that that's, you could get, I don't know what I'm saying. I'm just going to the last slide. I hope this was helpful. We'll see you at